Salam.
Good morning to all of you.
Morning.
Today I want to present my proposal on my research work related to the development of IEC 6250 base breaker failure protection scheme for TNB 132 kV substation. This proposal is for CD Fund project, and then I hope all of you can understand and approve my project for fun.
Consider to approve.
Proceed to approve.
Tak ada, tak pakai. Itu nak tunjuk je kalau nak pakai.
Okay, first our situation now.
Kuat-kuat so, tak dengar suara kau.
Okay, first our situation now in the conventional scheme.
Excited tak ada pun. Ulang balik sebelum slide tu. Masih balik pada title slide. Title, okay. I am very excited to be given this opportunity.
Okay, I am very excited.
You don't sound excited, kawan.
I am very excited. I am very excited.
To be given this opportunity.
I am very excited to be given this opportunity
To present to the technical board.
To present to the technical board.
My proposal.
My proposal. Which is entitled with the development of IEC 6950 base breaker failure protection scheme for TNB 132 kV substation.
Okay.
Okay, go to the next slide. Our situation now. For information, in the conventional scheme, circuit breaker failure is the condition that happens when the circuit breaker fails to trip or open the circuit during fault. Okay. Circuit breaker failure protection scheme is used as a backup protection that initiates tripping of all adjacent circuit breakers that are connected to the feeder of the faulty circuit breaker. It means when fault happen at one circuit and the breaker fail to trip the circuit, that's when we need some backup. This is a method on how we can trip the faulty breaker. Okay. The breaker failure scheme in the conventional way deploys hard wire, and that's mean using copper wire connection for transmitting the breaker failure.
Kuat lagi. For transmitting
the breaker failure signal from the relay of the failed breaker bay to the adjacent bay that is interconnected with it. Okay, these are some figure of the conventional scheme architecture of this scheme.
Alright.
Okay, this is one typical signal diagram of the substation.
Tanyalah soalan apa-apa. I have a question. What is the earlier slide? The diagram? What is this?
This is some figure or example of the scheme.
And the next one?
This is typical TNB 122 kV substation deployed scheme.
Oh, okay.
Okay. You'll see here. This is the architecture of the scheme. It requires bulk number of wire. It requires many wire termination, and also depend on the bus bar protection system, and then depend on the substation topology. That means when we have double bus bar, in this case, the reserve bus bar and also main bus bar. And then in the substation, the TNB substation, we have a single bus bar also for the other. And then we have number of feeder here. And then when we deploy the scheme, we cannot have a flexible scheme. That means we are depend on the hardware connection only. That means when we try to do some expansion of the station, we have to do so much wiring there. Fine, yeah. Bus wire for the tripping. Okay. Complication when we still use conventional scheme.
Thank you very much. Okay.
First, human error during wiring process. That means you have to make sure that the wiring is correctly connected to the correct point. There's too much point, and then we can easily exposed to the human error during the engineering process. Take a long time for terminating the wire to the correct point because we have to make some solder, the basic wiring process. I think the wireman should know how to wire it, but the time taken to make the wiring is so long.
Right.
And then high cost for the copper wire because everything deployed for the scheme using copper wire. We have to wire the copper wire. Have to wiring the copper wire from one feeder to the other feeder, and then with the long length of the copper wire for the scheme. And then it's not quite simple for any future substation expansion because when we have to expand the substation feeder, we have to make more wiring, and then we have to make sure that wiring is still in the correct process, and then exposed to the failure if the wiring connection is broken. Yes. This is the main factor that can lead for the system to be failed, for the breaker failure system to be failed, because the wire we cannot monitor in the real time situation. Okay. Any question from the control?
Okay, kita dia.
Okay, implication. When we still use this scheme, disadvantage of the scheme, high cost is required to install the scheme. Okay, based on our data, we need to have 50,000 per feeder to purchase the breaker failure relay, test plug, tripping relay, auxiliary multiplying relay, and copper wire. So much component for the conventional scheme.
So many components.
So many components for the conventional scheme. And then for the engineering work, we have to spend about 20,000 per feeder. And then imagine if we have 16 feeder in one section, how much we have to spend to install the scheme?
What is engineering work that related to?
Engineering work related to is subject to the contractor we have hired. I get the data from Chemical Engineering as approximate cost.
Approximate
Cost for this for
Maybe the consultancy.
Consultancy, yeah. Yeah. About 30K. Total cost for feeder is 70,000. And then the working duration is about 2 days per feeder. By implementing conventional way for the scheme. Okay, in our position now, with new technology, we have new standard named IEC 6250. Introduce.
There is an opportunity.
There is an opportunity
to reduce.
Oh, okay. There is an opportunity to reduce all of the disadvantage and
to reduce the cost.
To reduce the cost.
Explained earlier.
In the
by
using the new standard for the scheme. The standard is based on the IC 6150 standard introduced in 2005. This standard introduced the new communication service named GOOSE, GOOSE, not animal but generic.
Bukan ghost, goose. Ghost hantu. Goose. Angsa.
Answer. Okay, GOOSE stand for Generic Object Oriented Substation Event. This term is one of the communication profile introduced by the standard.
I have a question.
Okay.
Why just for breaker failure? How about the other breaker? Why just for breaker failure protection you choose for this?
Okay. Why you choose the breaker failure GOOSE message for only breaker failure? Because
not for the breaker.
For the other breaker, for breaker is a local issue. We have to monitor only the local breaker. But for the circuit breaker failure, is comprise the scheme for the substation for all the substation. And then by using GOOSE message or the GOOSE communication profile, we can distribute all the communication from one feeder to the other feeder, especially for the bus bar tripping.
Can we apply for the other breaker as well? Not
Yes.
for the individual breaker? Not
Yes,
for the
also.
breaker failure?
Yes, we can also apply for the individual breaker.
Why for this research not cover the
Because our scope now is for circuit breaker failure protection only. Okay. Okay, you can see from this figure, all the bulk wire has been replaced by using single line there. You can see. Only need a cable, Ethernet cable that can connect which is connected all the relay for the scheme. Okay, this is a typical substation of the DMB. And then how you can imagine how much wire can be what you call it? Can be replaced by the Ethernet cable using IEC 600 boost message here. This is a net switch, this is a Ethernet cable, and then this is a relay that comply to the standard. And then all of the substation are using this very simple architecture for the scheme.
Another question, why did you choose only one kV? How about the higher voltage?
For my project now, because to 7 kV they already have the bracket failure protection scheme. But for 120 kV, only typical substation have the bracket failure, such as Joe and Wolf protection. But on the other side of the substation, we didn't have any bracket failure protection scheme installed at the substation.
On new substation, there is on the
for new substation, it depends on what policy or what scheme or what the policy used at that substation. Because TMB engineering have invented 3 methods. One from the full IEC 600 substation. That means I think they will install it using this scheme. And then the other one is hybrid. Hybrid means conventional plus the IEC 650. And the third one, I think, what you call it, retrofitting on this typical function will be used as standard. Okay.
Now I have a question for you. What are you proposing? I'm confused here. Are you proposing to investigate something, or are you proposing to replace?
Okay, I propose to replace.
Replace or to install new?
To install new. Install new.
Install new.
Yeah.
So you're not researching.
Not researching. Yes, I think.
I'm actually confused. What is the proposal again? Proposal to replace, install, or proposal to research?
Still research, but
Research what?
New technology.
Research what?
New technology. Adopting new technology.
But the technology already, the products already available in the market.
Yes.
You just install.
Yeah.
They nak adopt the current TMB infrastructure into the new technology.
There is no
They have to change.
What is this research? I don't understand.
like research. Their research area.
What are you researching?
Okay, for your question. Okay, this new standard in TMB, we didn't have already have any scheme adopting this standard, because still using copper wire based connection.
But if this system, if this technology already installed at the other utilities, meaning that just plug and play the nearby and install the things.
I think they still need to work some configuration, because they need to adapt the whole system to the new technology. So
Then that means
that is the reason.
Then that means you are investigating the right configuration to be used when installing this new device.
Yeah, you have to investigate first how to engineering, how to make the standard fit to operate on our system. As I have to look at some logic.
This one already approved by.
Not approved.
Have you presented to?
I have presented to the board meeting.
Ada respon? Cassette.
That's approved.
Yelah, sometimes the board also less critical kan. But if I want to be really critical, so my question is, what are you researching kan? Because we are research, is it? So you are researching. So in your words now,
investigate the new technology that can suit in our system.
no, investigate the correct configuration
Correct application.
Code application.
Because dia ada dah benda dah ada kan, just to put at certain places.
To investigate the correct application of whatever is it lah, of the IEC 61850 goose message. Yeah. Okay, next slide. Okay, that was to design.
Okay, first I have to design first and formulate the logic of the breaker preparation, including IC 610
Kuat.
Okay.
So the objectives of my research proposal kata.
The objective of my research proposal is to design and formulate the logic of the breaker failure protection with IC 610 goose message.
Okay.
Number 2, to model the breaker failure logic inside some software, power system software, for testing the performance of the scheme with IC 610 goose message. And then third, to identify the practical engineering process to link the signal of the breaker failure protection using IC 610 goose message.
Okay.
This is my third action I take to form research. And then the project cost.
Yes, this is what. Okay, good.
It's about 525,000, including manpower costs, research material, traveling, and also research equipment. Only that. Research material we can have because we have already bought it in our lab now. Research equipment is new thing that we have to change for this project.
Okay.
And then benefit, you can apply for the project. First, enables the user to supervise the communication channel from one link to other link. In the conventional scheme, we cannot monitor the wiring connection. By using this message, we can monitor it online.
Okay. Yeah.
And then simplifies the engineering process with flexible programmable protection and communication scheme configuration. I have to identify first how to format the logic and then standardize it using IC 610 engineering process.
Okay.
Medium you are using the fiber optic.
Reduce the likelihood of human errors in setting up the communication channel between breaker failure relays.
Okay.
That means on everything using software.
Okay.
Cost reduction by adopting IC 610 scheme. This is how the breakdown of the total cost for the scheme. Yeah.
Engineering work still there.
Okay.
I still depend on the contractor cost. And the total cost of 40k. Compared to the commercial, we have to spend about 70k per feet.
Okay, louder.
Okay, this
The total cost, louder. The total cost.
the total cost by using IC 610 scheme is about 40,000 compared to
Which is 30,000 less.
which is 30,000 less compared to the conventional scheme.